Red areas show that more weight is landing on the left foot than on the right. Next, a 3D impression in foam. It goes to the production department where technicians fill it with plaster. Once it dries, they extract an exact model of both feet. Now they can construct the orthosis piece by piece. Most of the components are made of different types of polyurethane, a lightweight thermoplastic. Each type is designed to produce a specific effect at a different phase of the patient's footstep. For example, the blue base is made of rigid polyurethane that holds the foot in the correct position. At the front, dense black polyurethane helps propulsion and reduces stress on that side of the foot. They cover the assembled orthosis with a sheet of glue and put it into a vacuum press. The press applies heat to activate the adhesive. It sucks out the air between the components and compresses them tightly together. When the orthosis comes out, they place it on the model of the corresponding foot. Then it goes into a different vacuum press to mold it to the shape. They add made-to-measure corrective parts in latex foam. Then, using hypoallergenic glue, line the orthosis with a soft polyurethane. All that's left to do now is buff the orthosis. This smooths all the surfaces. To ensure the orthosis delivers the goods, the patient redoes the key tests while wearing it. Remember that scan showing red areas? They're gone now because the patient's feet now bear her body weight equally. This patient has arrived with a doctor's prescription for a knee brace. The orthotist analyzes his mobility, flexion, and balance, then sends the technical specifications to the production department. There, technicians make a model of the leg. They begin by positioning the leg at a 12-degree angle and wrapping it in plaster bandages. While waiting for the fast-set plaster to harden, the patient chooses a decorative pattern for the outside of the brace. The hardened cast serves as a mold. Technicians pour in plaster, let it harden, then remove the cast. After smoothing the surface, they draw technical markings, then install the lightweight aluminum joints that'll enable the orthosis to bend. Now they run a sheet of plastic through an oven. This is high-memory plastic, meaning that when you form it, it remembers the shape and maintains it. The design the patient chose comes printed on transfer paper. They use a laser thermometer to ensure the plastic is at the perfect temperature for the pigments to penetrate properly. They carefully position the hot decorative plastic on the model. Using a vacuum bag, they remove the air and press the plastic on tightly. The plastic sets in about 2 minutes, maintaining the form. They cut the required shape, line the inside, and sand the edges smooth. Finally, they attach straps to fasten the orthosis to the leg. The orthotist checks the fit on the patient, then runs various tests to make sure the orthosis is doing exactly what it's designed to do. Ever wonder how ballerinas manage to dance on the tips of their toes? It takes years of training, remarkable skill, and special ballet slippers. These toe shoes are handmade in what's truly a manufacturing pas de deux, a graceful pairing of traditional methods and modern materials. They sew the toe shoe's exterior from 3 pieces of satin. They cut those pieces using a press equipped with a metal die. It slices through enough fabric at a time to make 4 pairs of shoes. They also cut a pure cotton lining for each piece to protect the dancer's feet from irritation. This V-shaped piece is called the vamp. It'll become the front half of the shoe. The seamstress extends the V by attaching the 2 other satin pieces called the quarter panels. They'll form the back half of the shoe. She sews the ends of the V together, making a heel seam, which she reinforces with a rayon ribbon. Then she feeds the same type of ribbon through a special machine that folds it in half over a drawstring. She stitches it to the top perimeter of the shoe. This encased drawstring will enable the dancer to pull the shoe tightly around her foot. Now they put the satin upper onto a wooden form to check the sizing. It's absolutely critical that the height of the vamp be correct to within 3 millimeters. If it's even slightly off, the top of the shoe will cut into the dancer's foot. The shoemaker nails the cotton lining to an insole on the bottom of the form. The insole is made of rigid cardboard for support, imbued with plastic for flexibility. After trimming off the excess, he glues the lining onto the insole, making neat little pleats. Once the glue dries, he removes the nail and trims the excess pleating to eliminate any bumps that would irritate the foot. Now they sculpt the toe box, the hard encasing inside the tip of the shoe. It's made of papier-mâché, only instead of paper and paste, they use fabric and paste. Then they soften up a piece of resin-coated cotton in water and apply it on top. Next, they saturate 2 pieces of burlap with paste and apply them one after the other over the cotton. The paste is made of flour, water, starches, and a rubber and plastic-based resin that hardens to a semi-flexible state. That's key because the toe box has to be stiff enough to bear the dancer's full weight, yet flexible enough so that the ballerina can move fluidly. Now the final layer of fabric, a piece of pure cotton. They wrap the toe box in plastic